product that we've got in, customers were asking for our smaller hydraulic tool, the YCP 120C. It's basically a couple of ball dies for swaging steel ball terminals onto 1mm, 1.2mm, 1.5mm and 2mm cable. And in imperial, that'd be 1/16 cable and 3/32. The type of terminals it swages are MS20664 shank ball terminals and BA3 Boeing type ball terminals. I'll just demonstrate the larger die set. And both these die sets are available as single units. You don't have to buy both types. You can buy the ones for the 3/32, or you can buy the ones for the 1/16 cable, or you can buy both sets. They don't come with the tool as standard. They are an optional extra, and they are available on the website now. So you'll see them underneath the tool. We've demonstrated this tool before, this YCP 120C tool. And there is a video for this already online. You can see it's quite a small tool, this, and the pressure of this tool is suitable for swaging these size of terminals, and although we do also do these dies for our bigger tool, the YCP 240C, this tool does seem to be more in proportion with these type of ball fittings. So you see the head swivels there to allow you to get the right profile for how you're going to use it. So I've got here a bit of military spec 3/32 cable, which is the biggest type of cable these fittings would be used on. And I've also got the MS20664 3/32 shank ball end. So I'm just going to put that on, and you'll see it's on the cable there. If you just slightly fray the end, it'll just keep it in place. There you go, like that. Let's see if you can see that. Okay. And I've loaded the dies up. That again, they retain quite easily into the tool. And you can actually, if you're going to do a lot of work with them, there's a little set screw here and on the ram of the tool that you can tighten up with an Allen key. You don't have to really tighten it very tight, just enough just to retain the dies. Don't tighten them too much. It's a very, very small set screw. But it's worth doing if you're going to do a lot of repetitive work with the same die. So just turn the action on, and what that does, that activates the hydraulic system. There you go. So, and these tools click out once they hit their maximum pressure. You'll hear it like that. So that's about 6 tons on the head. And then to release the dies, you just do that. Now you don't have to release them all the way down. That'll save a bit of time. So you can just turn that little dial there, and it'll open the dies just sufficient to pop the next terminal in. So I'm just going to put this terminal into the die, and might need to open that a little bit more actually, just to get that in. There you go, like that. And then I'm just going to advance the die just to hold the terminal in place. Like so. There, like that. Okay, so now the terminal's trapped in the die, but the cable's still free to move about at the minute. Haven't actually fully swaged this fitting. So this way you can get the end dead right on the cable and just get it how you want it. Or if you need the fitting further along the cable, you can move it along at this stage. And then I'm just going to advance the die now. This will actually swage the terminal on, and I won't be able to move the cable anymore then. Right, so this is actually onto the fitting now, so I'll just complete this action. The cable's still in place. Yeah, okay, so you'll see, there you go, so that's the first swage. So I'll just release that in the die. You'll see there's a little ridge line down the fitting, Now that is okay to swage that back in. So what I'll do is I'll just turn this fitting 90 degrees, like so, and then again just repeat the process like that. The finished ball terminal, shank ball terminal, is done now. Now this terminal is good for about 90% of the cable breaking load minimum. So for example, if you had a 1-ton cable, the ball would be good, shank ball would be good for 900 kilos breaking strength. In our tests, we normally find that the cables and B, the terminals break or fail much higher than this. So we will do a demonstration test to show the efficiency of these terminals. What I'll do now is I'll just cut this cable and fit one of the BA3 ball terminals to the other end. Now they're a minimum of 50% efficiency. So this is a little BA3 ball here. They're a minimum of 50%, and again we find that they break much higher than this, but that's what we kind of rate them at. So okay, so that's that little ball on there. Here's the tool again. I'm just gonna, there you go, I'm just gonna put it in the die and swage this on. Again, right now the fitting's trapped in the die, but the cable's still free to move at the moment, so I can if you can see that on there, but I can actually adjust the cable to whatever I want. So if I leave about 3 mil or 1/8 of an inch sticking out, and then just swage this on in the same process. So again, you'll see, and obviously it's easy if I do this on a surface, but it's just to show you that it's not that hard to do the swaging operation. Okay, so that's the first swage on the ball. And you'll see there's a little ridge line maybe on here. I don't know if you can see that on the camera, hopefully you can. And then I'll just turn that ball 90 degrees and get rid of that ridge line by swaging that back in. Okay. So that's that. Okay, so we'll just go and get this tested and show you the. So this is the test rig setup that we've got done. There's a little cable held in place there. This cable's got a 417 kilo minimum breaking load.